All right, solving proportions. 8.4, obviously we're doing 8.5, but 8.4 talks about solving proportions using equivalent fractions. Okay, that way works some of the time, but with the proportions that we're going to be dealing with mostly, you're going to need to know how to do it the next way, which is using cross product. And so I usually, with the honors track, we usually don't go over that section because it's pretty self-explanatory. And so I want to go on into solving proportions using cross product. Cross product always works, okay? Regardless of what the proportion is, it always works. Now, we need to understand what a proportion is, okay? A proportion is a relationship between two ratios that are equal, or another word, equivalent. And basically what it's going to look like is two equivalent fractions. Okay. For example, if we had the fraction 25/75, okay, well, we could reduce 25/75 down to 1/3. Okay, and so you might have a proportion that looks like this: 25 over 75 is equal to 1/3. Okay, that's two fractions. What do we also know? Fractions can be ratios. So that's two ratios that are equal to each other or equivalent. I use the word equal and equivalent because in your proportion you will have an equal sign. So they are equal, okay, but they're not equal in the sense of they're both ratios have exactly the same numbers. They're equal in the sense of that they're equivalent. Okay. Now, what we're going to be discussing today is we take a ratio, for example, like this: 9 over 2 equal 36 over n. Okay, so instead of basically giving you the two ratios, they've given you one ratio, and they want to find out, okay, what the missing part is of the other ratio. Now, the variable, in this case n, can be in any part of the ratios. It could be in either of the denominators, or it could be in either of the numerators. It's not always going to be, on the bottom right-hand side. Okay? But the process is still the same. We use cross multiplication. Okay? We use cross multiplication to solve the proportion. Okay, you will understand that it's one of the reasons that I've started using the word Jimmy Neutron with you. When we talk about cross-canceling, we're multiplying fractions, and we talk about cross-canceling, and we draw the Jimmy Neutron. One of the reasons I do that is because I'd rather use Jimmy Neutron, because now we're talking about cross-multiplication, and people get it confused. They'll go, oh, okay, so we're cross-canceling. No, you're not cross-canceling, you're cross-multiplying. We're not saying that, 2 goes into 2 once, cancel it out. 2 into 36 goes, 18 times, I'm canceling it out. We're not saying that, okay? We're not saying that. We're saying cross-multiplication. So when we're talking about cross-multiplication, what we're talking about is we take the bottom number of the first ratio and multiply it times the top number of the second ratio. And then we take the bottom number of the second ratio and multiply it times the top number of the first ratio. So what it looks like is this: 9 times n is equal to 2 times 36. That's the cross multiplication. Okay, we are cross multiplying. Now we just have a simplistic equation. We have 9n equal 72. And then I have to solve it. Okay? It's a one-step equation that we're doing multiplication in. So to solve it, we do the inverse operation of multiplication, which is division. And so to solve this equation, we're simply going to divide by 9 to both sides. And n is equal to 8. Now, I want to show you on this specific problem what they talk about in 8.4. Okay? In this specific problem, if I redid the proportion, okay, if I redid the proportion, basically, what did we do to 9 to make it 36? Multiplied by 4. And so to keep them equivalent, you would have to do the same thing on bottom. Okay, and so what they basically did in 8.4 is they said, okay, I can multiply that by 4 to get 36. So I do the same thing here, and I get 8. Now, that's fine when you're dealing with simplistic proportions. Okay, but most of the ones you're going to do today are not going to be simplistic. In other words, you're not going to be able to tell right off what you did to this number to make it this number. Okay, let me give you an example of that. You know, like the 6th or 7th one you're going to do today is 6.8 over z. Make that better so it doesn't look like times. 6.8 over z is equal to 2/5. Okay, so this one you realistically, it would take you, maybe you can eventually, but you've got to say, okay, what did I do to 2 to make it 6.8? I got to do the same thing to the other one, and so ends up being a little bit more complex, and that's not one of the even really the more complex ones. You're still going to end up with a whole number on this, okay? And so what you do is you cross multiply. So I have 2 times z equals 5 times 6.8. 2 times z is equal to 5 times 6.8. Okay? Now, what that gives us is 2z equals 5 times 6.8 is what? What? 34. That is correct. Okay? So now I just solve it. I divide by 2 to both sides. The 2 on the left side cancel. 2 goes into 34 17 times. Okay? Cross multiplication always works. Every single proportion. Providing that you do the math properly. Now, if you take, 5 times 6.8 and you say it's, 340 or 3.4 or something like that, then yeah, you're going to miss it. Okay? The math still has to be done by your brain, but the process of cross multiplication always works. Now, we take one, for example, like this, a little harder. 2.2 over c is equal to 5.5 over 11. .2 over c is equal to 5.5 over 11. Okay? We still do the same thing. We cross multiply. Remember, I am not going from top to top, bottom to bottom. Okay, I'm not going from top to top, bottom to bottom. I'm not taking 2.2 times 5.5. That would be regular fraction multiplication. Okay, so we have 5.5 times c equals 11 times 2.2. Now, understand that we could flip that order. In other words, I could say, over here on the left side, I could say 11 times 2.2 is equal to 5.5 times c. Okay? But what we've always done is, and what I've always told you is that the number always has to be in front of the variable. Okay? Just the way we need to do it is your number's always in front of your variable that you're multiplying by. So that gives me 5.5c equal what? Do what? 24.2. Anybody else get that? That's right. I just want to make sure y'all got that. 24.2. Okay. Now, comes a little bit more difficult because now we're having to deal with decimals on both sides of the equation. Okay. And so I've got to divide by 5.5 to both sides. On the left side, they cancel, leaving me with C. On the right side, it's 5.5 into 24.2. Well, the problem is I can't have a decimal in my divisor, the number on the outside of the bracket. So I have to move the decimal one place to the right. Same thing on the inside, one place to the right. If I don't do it on the inside, then I don't have an equivalent expression. Whatever I do to the outside of the bracket, I have to do on the inside of the bracket. So if I move it twice on the outside, I have to move it twice on the inside. And so that gives me C is equal to 55 into 242. Okay? So how many times does 55 go into 242? 4 times? Be 0, carry my 2, that would be 22. That would leave me with a remainder of 22. Add a decimal, add a 0, and bring that 0 down. Bring up my decimal and my answer. 55 goes into 224 times, and so that gives me C is equal to 4.4. Now, that's one of the more difficult ones that you will have, okay? Not necessarily that hard, it's just a matter of remembering our rules when we get to decimals. Remember, dividing decimals, you can have a decimal on the inside of the bracket, but you cannot have one on the outside. Okay, so there's a decimal on the outside of the bracket, and that's your divisor. If there's a decimal in your divisor, then you're going to have to move it. Okay? So if that would have been, let's say that would have been 55 times C is equal to 11 times 2.2. Okay? Then you would have had 55 times C equal 24.2. And then you divide 25 into 24.2, you just divide it. You don't have to move anything at that point. Okay? I want you to try this one on your own. 7 over 10 equal K over 8. 7 over 10 equal K over 8. All right. Who has an answer? Joshua. No. It's a decimal, but it's not 7.2. Xander. 5.6. That is correct. Okay. Make sure we remember see how we got it. You have 10 times K and 7 times 8. 10 times K is equal to 7 times 8. That's 10K equal 56. Now, on this one, we're dividing by 10 to both sides. Cancels here, so K is equal to 56 over 10. Well, remember back earlier in the year we talked about powers of 10 multiplying and dividing by powers of 10. Since I have 1 0 right there, that means all I have to do is take the number 56 and move the decimal one place to the left because I had 1 0. And that gives me K is equal to 5.6. Now, you can actually divide it out. 10 into 56 goes 5 times, be 50. Remainder 6. Bring down a 0. Bring up my decimal. 10 into 60 goes 6 times. Okay. So either way, it would have worked on that. All right, let's look at number 22, word problem. Okay? Number 22, a word problem. I believe it's talking about internet connection, and said a digital subscriber line, which is DSL, connection to the internet transfers 42 megabytes of information in 5 minutes. How long would it take the connection to transfer 75.6 megabytes of information? So, basically what you have is this. We have said that a proportion is a relationship between two ratios that are equal. Okay? It'd be like this. Let's say in this class we had 16 people, and of those 16 people, 4 of them made A's. Okay? On a test, exam, whatever you want to say, a project. Okay? 4 of them made A's. And I want to know, okay, if that same ratio holds up, if I've got 48 in a class, how many are going to make A's? Okay? And so that's a relationship that you're comparing. Okay? Same thing here. They're saying that in 5 minutes we transferred 42 megabytes of information. Okay? Well, that's a ratio. Okay? A ratio is a rate. One thing is a rate. Megabits and minutes are not the same unit of measurement. Okay? So your first ratio then is 42 megabits. I call it megabits, thank you. In 5 minutes. Okay? Now, that could be switched. It could be 5 minutes, okay, over 42 megabytes. Okay? Either way is correct. Okay? The problem that you have is on the other side of the equal sign. So I have 42 over 5 is equal to the other part of the information they've given me. The other part of the information they've given me is they want 75.6 megabits. No, it's spelled English, megabits, not bytes. 75.6 megabits of information takes how long? So, on the other side then, we're missing the minutes. Okay? We're missing the minutes, and they've given us 75.6. Okay? Once again, your proportion could be set up like this. Either one is correct. What you've got to make sure that you have is, this here is minutes and minutes, megabytes, megabytes. Okay, you can't flip the two. In other words, it can't be this. It can't be 5 over 42 is equal to 75.6 over x. Okay, it can't be that. That's wrong. The reason it's wrong is because you have minutes on top of the first ratio and megabytes on the top of the other ratio. You can't do that. You've got to have the same unit of measurement on the top, same unit of measurement on the bottom between the two ratios. Okay? If you did it the first way here or the second way, you're still going to get the same answer. Okay? If you do the mathematics of it right. So now we just cross multiply, and we have 42 times x is equal to 5 times 75.6. Okay? So we multiply it. 42x is equal to 378.0. Okay, which is 378. Okay, and so now I'm going to divide by 42. That cancels, giving me x is 42 into 378. Let's see, 42 times 10 is 420, so probably 9 times. And that would be 8 378. So it will take 9 minutes to transfer that information if the same ratio holds true. Okay? Now, proportions is where insurance companies for car insurance and for house insurance, where insurance people decide how much risk there is. Okay? What I'm talking about is this. For example, a student or a young person who is 16, 17, 18 gets their driver's license. Okay? Well, in the state of Texas, the insurance company will have ratios of the number of 16 to 18-year-olds that have their driver's license compared to the amount of 16 through 18-year-olds that get in wrecks. Okay? And what they'll do is this. They'll say, okay, we've got a ratio of 3 out of every 4 teenagers, 16 to 18, get in wrecks in their first year of driving. Okay? So what that tells you is that 75%, now I don't know if that's the actual number. I know it's fairly high. I don't know if it's that high, but I know it's over 50%. Okay? And so if it's 75%, there's a 75%, let's say all of y'all are 16, and there's a 75% probability that 75% of you are going to get in a wreck. Okay? So do you think the insurance company is going to charge you a small amount of money to protect you or a large amount of money to protect you? A large amount of money to protect you. Okay? Because they feel like the ratio says that I'm going to probably have to pay out for this person. I'm going to have to pay for their car. I'm going to have to pay for whatever. Okay? Now, as you get older, your insurance starts to go down because it's less likely that you'll be in a wreck. Okay? So they don't have to insure as much. They don't have to take the chance of you getting in a wreck. Now, once you get past a certain age, then it starts going back up again. Because the older, like, for example, 75, 80-year-old people don't have the same reaction times that 40 to 50 to 30 to, those people do. Okay? Now, the reason that, for example, for girls, when a girl gets to 21, their insurance starts to go down. For a boy, it's 23 to 24. Okay, because they tend to be more radical drivers, more, driving all over the place, all of that. Okay? So, that's what it tends to be. They tend to be, boys tend to be more angry. They tend to have anger management issues. Okay? And so they'll drive fast and all that. But, just like, for example, another example, house insurance in the state of Texas right now is sort of high because we've had so many hailstorms. Okay? And the hailstorm, when a hailstorm hits your house, it ends up hurting your roof on your house more than anything else. More than anything else, really, when you have hailstorms, if you're not dealing with a car and you're dealing with your house, it hurts the roof. Doesn't usually break windows. Occasionally they will, but usually they don't have to replace windows or anything like that. When I lived in San Angelo, when I was in my first year of college, we had a real bad hailstorm, and the hail was the size of grapefruits. And you would drive down the road, and you would see houses that were made of wood instead of brick, and they would have giant holes in the side of the house where the hailstones actually went through the walls of the outside of the house. We had at the time I was working at a credit union, and we would have people return their cars that they had loans on because the roof of the car, like a roof of a truck, was level with where the window started to go up. The roof was literally level where you could not see in, like you're looking in the driver's side window of a car, the roof was below that. because it was such a bad hailstorm. And so there was billions of dollars of damage done on the side of it. Didn't hit the whole side of San Angelo, didn't hit the whole town of San Angelo. It just hit in a little suburb that was out north of San Angelo, and it was pretty bad. I mean, it was hailstones that were about, they were grapefruit size. Okay, so you can imagine, here they show the little golf ball hailstones and how bad damage they do, and so it was basically. I saw one of the dents is basically that size right there. So if you'd have been outside in it, you would die. I mean, it would have been dead. Okay? So that's one area. Quiet now. That's one area that they use proportions is in the insurance industry, and it's called risk analysis. So they're going to take a population of people and say, okay. Just like, for example, if you live in Dallas County, in Dallas, where Dallas is, you pay more insurance. Your insurance rates are higher regardless of what age you are because there's more people, more traffic, more wrecks. Okay? That's their analysis. And so what they're saying is they'll take a general area, they'll say, okay, in this area right here, 2 out of every 9 people get in a wreck. So if 2 out of 9 people get in a wreck and we're going to transfer that to our whole city that we have insurance over, which is 1 million people, then that's going to tell me, and they're going to tell you the exact numbers, and they're going to say, okay, we need to charge this amount to protect that risk. Now, are they wrong? Sure they are. Okay? Like, for example, we could take all of you off, y'all are 16. None of you may get in a wreck. Okay? But you take the next class, if none of you get in a wreck, then the proportion or the ratio is going to say that then most of the people in the next room are going to get in a wreck. Okay? Because eventually the proportion, the ratio balances itself out. Okay? So that's one of the many ways that they use proportions in the real world and in the real times that that we're looking at. Zach?
Is there insurance for if you trip over or not?
Well, you have health insurance. I mean, it would be covered under your health insurance. So, all right. Your homework. You're doing 8.5. And you're doing 2 through 24. Okay, 2 through 24, and you still got almost 15 minutes left in class. So let's go and get started on it, and you can get a lot of it done. All right, 2 through 24, 8.5. If you have questions, raise your hand, and I'll come help. Get started.